Now, the force that we found was restricted to the case where the area is normal to the z direction. We aligned here the area so that the normal is in the z direction. So it cannot be the full Monty. Let's consider an area patch that is in a generic orientation. For this patch, the normal and hat is a linear combination of the unit vectors in x, y, and z. So let us draw an infinitesimal cube around the origin. So each surface is normal to the respective unit vector. What we did before was to consider only the surface that is normal to z. Therefore, we had these three components of the stress. That was simply called sigma x, sigma y, and sigma z. But considering this cube, each surface of the cube will be subject to pressure and shear. The pressure and shear on the surface z is different than the pressure and shear on the surface y, which is different than the pressure and shear on the surface x. So each surface has a force acting on it. Each of these forces is decomposed into three force components, one in each direction. So we need a new notation. We're going to give two indices to each stress. The first index is representing the direction, and the second index, the surface where this is being acted on. So for the x surface, the second index here gives you the surface, and the first index is the direction of the stress. So this is the stress x on the surface x, the stress y on the surface x, the stress z on the surface x. Likewise, for the surface y, this is the stress x on surface y, stress y on surface y, and stress z on surface y. Same thing for the z. On the z is the same quantities that we had before, sigma x, sigma y, and sigma z. We're just adding another index to represent the surface where it is acting.